We're going to continue in this unit talking about solving quadratic equations. Remember, quadratic equations can be, but don't have to be, in the form ax squared plus bx plus c equals 0. So far we have looked at factoring as a technique. And this is the format you'd like something to start out in for using factoring. The method we're going to talk about in this lesson is called the square root property, and it needs a different format than we have right here. The format it needs is, I'm going to use capital X squared is equal to b. If you have something squared equals a constant. Now the something squared could be something like this. It could be very, very complicated in here, but it has to be something involving x squared equals a constant. Could just be x squared equals a constant. Either way, x is equal to plus or minus, that's a joined sign, positive or negative, square root of b. In this case, it would be x plus a is equal to plus or minus the square root of b. Either way, now this one would require more work to get x isolated. And there could be several steps. But the key to the square root property is, if you have something involving x squared equals a constant, you take the square root. There is a little bit involving absolute value that causes you to get a plus or minus. I will leave that to the college algebra classes to talk about, but it is important that you get both positive and negative square roots of x. Two answers for quadratic equations. Let's take a look at some of these problems and use the square root property. The first one, I have x squared is equal to 4. It's in the appropriate format. It is x squared equals a constant. All right, I'm going to take the square root and then take the positive and negative square roots of 4. You'll see that I always write this step down. Sometimes this number is a perfect square. You can simplify it and get two answers that are rational. Sometimes this is not a perfect square, but you could simplify it. Sometimes this is negative and you'll get imaginary answers. So we will always simplify, if we can, the radical of the constant. When you answer this in my math lab does not have this combined sign of plus or minus. So you have to literally separate them, positive and negative 2, separating them with a comma. Okay? Let's look at number 2. I have x squared minus 10 is equal to 0. Well, the instructions tell me to use the square root property. I can't do that in the format it's in. The squared has to be alone. So I'll add 10 to both sides, and I have x squared is equal to 10. And now it's in the right format for the square root property. X squared is equal to a constant. Take the square root of that side for x, positive and negative, square roots of 10. Always ask, can you simplify? And the answer in this case is no. You cannot simplify the square root of 10. There's no perfect square factor. So on a piece of notebook paper, that would be fine. In math lab, you're going to need the negative square root of 10, comma, the positive square root of 10 in any order. Make sure you are outside the radical, that you're not under the radical when you put the comma. Two answers. All right, let's look at another one. I have x squared is equal to 12. The format is correct. I have x squared is equal to a constant. So I take the square root to get x, and I take the positive and negative square roots of 12. I always ask if I can simplify. Well, yes, I can. The square root of 12 is the square root of 4 times the square root of 3, which is 2 times the square root of 3. So x is equal to plus or minus 2 times the square root of 3. In MATLAB, you have 2 times the square root of 3, comma, negative 2 square root of 3. When you get irrational answers, they will be conjugates. You would have learned that in the previous module. They are conjugates. All right. The next one is a little more complicated. I have x plus 7, quantity squared, is equal to 25. It's not just x, but it is an expression involving x, quantity squared. Something squared equals a constant. So it is ready for the square root property. Take the square root of the left to get x plus 7 is equal to plus or minus the square root of 25. Can you simplify this? The answer is yes, because it's a perfect square. So I get x plus 7 is equal to plus or minus rational 5. Now I need to solve for x. I'll subtract 7. Let me recommend that you put the minus 7 in front. People make fewer mistakes if you do that. So I have negative 7 plus or minus 5. All right, what are my two answers? Well, I have x is equal to negative 7 plus 5. I have x is equal to negative 7 minus 5. So I have x is negative 2 or x is negative 12. So the negative 7 stayed negative. You add it to 5 and you subtract 5. Those are my two answers. All right, next one, I have 2x minus 3 quantity squared is equal to 8. Can I use the square root property here? Yes. It is something squared equals just a constant number. Take the square root of the left for 2x minus 3 is equal to, got to have plus or minus, the square root of 8. Can you simplify? The answer is yes. The square root of 8 is the square root of 4 times the square root of 2, or 2 times the square root of 2. So I have 2x minus 3 is equal to plus or minus 2 times the square root of 3. Oops, sorry. 2 times the square root of 2. I need to solve this for x. This is an irrational piece, so keep that in mind. You're going to add 3. Please put it in front. I have 2x is equal to 3 plus or minus 2 times the square root of 2. Divide by 2. X is equal to, get a little more room, 3 plus or minus 2 times the square root of 2 over 2. You will need to separate this into two distinct answers. The first one being 3 plus 2 times the square root of 2 over 2. Make sure your comma is away from the fraction. 3 minus 2 square root of 2 over 2. You could only reduce if this number, and this number share a common factor, and they don't. 2 would go into this term, but it does not go into this term, so you cannot reduce this fraction. Okay, I think we have one more using the square root property. I have 4x minus 1, quantity squared, is equal to negative 25. Is it in the right format? Yes, something squared equals a constant. Take the square root, so I have 4x minus 1 is equal to plus or minus the square roots of negative 25. And then I ask, can I simplify? The answer is yes. This is a negative. radicand, which means this is plus or minus 5i. So I have 4x minus 1 is equal to positive and negative 5i. It is an imaginary quantity. I need to finish solving for x, so add 1, do it in front. I have 4x is equal to 1 plus or minus 5i. Divide by 4. And I have x is equal to 1 plus or minus 5i over 4. And in MathLab, you would need to separate this into two answers, 1 plus 5i over 4 and 1 minus 5i over 4, which, by the way, are conjugates also. So if the answers are irrational, you get conjugates. If the answers are complex, you get conjugates. All right, that was our second method for solving quadratics. We have factoring, and now we have the square root property. Try a few of those on your own.